Okay, so I'm going to finish the first section of Unit 5. This is day 2. So finding minimum and maximum values of a quadratic function. Excuse me. As you know, quadratic functions always graph parabolas. So if the parabola is opening upwards, then we have a minimum value, of course, right there. And we'd be talking about the y value. And if that parabola is opening downwards, we have, of course, a maximum. And that is the y value. So let me go to black ink if I can figure out what's going on with my electronics here. Just a second. Oh, here we go. Um, these are always found at the vertex. Specifically, it's the y value. The y value is the max and min, and the x is where that max or min is happening. So for example, for determining whether the given function has a max or minimum value, then find that value. So we see the leading coefficient is positive. That means I'll put here that, excuse me, let me do something really quick. Ah, excuse the delay, folks. Okay, that'll be a little bit easier now. In any case, here that is our a. A is greater than 0. Therefore, our parabola is going upwards, so it has a minimum value. And to get that minimum value, we have to find the y-coordinate of the vertex. Before we do that, we're going to find the x-coordinate of the vertex. So x is equal to negative b over 2a, or negative 1/2 over 2 times 1/4, which is negative 1/2 over negative 1/2. Anyway, positive 1/2. So x is equal to negative 1. I plug that into my function. 1/4 times 1 squared plus 1/2 times 1 minus 1 gives me, what is this, 3/4 minus 1, negative 1/4. So minimum value is negative 1/4. B, we see that A is less than 0. Therefore, we have a parabola that's looking like this. It has a maximum value. I could find that out the same way. So try to do this by yourself without watching me do it, and then just confirm that you did it right. That's our max value, 27. Example 5, determine the quadratic function with a given vertex and additional point. Now think about how many equations you know, or how many forms you know for quadratic functions. You should know 2. I'm going to write them here on the side. Hopefully you could squeeze it in on yours. First one is standard form. F of x equals ax squared plus bx plus c. The second one is vertex form. F of x equals a times x minus h squared plus k. And don't forget that square when you're doing those forms. That's what make them quadratic. So when you're starting these problems, the first thing you need to do is choose which one is appropriate. Now, since they're giving us a vertex, we are, of course, going to start with vertex form. F of x equals a times the quantity of x minus h squared plus k. So I'll plug in first just my vertex. X minus -1 gives me x plus 1 squared plus 8. And now I have to do something with this point. Now the y-intercept being 6, I'm going to write that as coordinates. That is 0, comma 6. So f of 0 is equal to 8 times 0 plus 1 squared plus 8, and that all should be equal to 6. Now I have this equation I could solve right here, which is a plus 8 equals 6, or a equals -2. So my the quadratic function, I now have all the pieces that I need. It's -2 times x minus, excuse me, x plus 1 squared plus 8. Just like we did last time, go ahead and work through B while I do it silently, and then you can just check your answer with me. I'm gonna get rid of a little bit of this stuff here, get that out of the way. Okay. And make sure to pause it if you haven't finished that one yet. Example 6, and have an application. The figure shows when a football is kicked, the nearest defensive player is 6 feet from the point of impact with the kicker's foot. The height of the punted football, f of x, can be modeled by the function that you see there, where x is the ball's horizontal distance in feet from the point of impact with the kicker's foot. Okay. In other words, if you were to plug in a 2 in for that x, then you would be able to see the height there at 2 when x equals to the horizontal distance of 2 from the kicker's punt. Okay, so the maximum height of the punt shown. What is the maximum height of the punt, and how far from the point of impact does this occur? Now let's get a big picture here. Take a look at the function. What kind of function is that? Quadratic. Notice that leading coefficient is negative, which means if we were to graph it, it would graph a parabola that is opening downward. So what we're seeing here is actually the very beginning of a parabola that's doing something like this. Even though it looks linear, it's part of a parabola. So to find the maximum height, what do we have to find? The vertex. So let's do that. Excuse me, x equals -1.18 over 2 times -0.01. Negatives cancel. We have 1.18 over 0.02. It says it's a calculator problem, but this is pretty easily done without a calculator. And I do urge you to, when possible, do without a calculator. So of course I move that decimal point over twice, multiplying top and bottom by 100. 118 divided by 2 is 59. So is that the maximum height? No, that's the x value. I need to plug that in to my function. F of 59 equals -0.01 times 59 squared plus 1.18 times 59 plus 2. Now, if you think I can do that without a calculator, you might be out of your mind. So go ahead and plug that into your calculator just for practice using your calculator and to get an answer. And the answer I got is 36.81 feet. Now, this is a word problem, so it would be appropriate to say the maximum height is 36.81 feet. I'm going to be a little bit lazy here, but if this were a test or a quiz, you know I would be writing that as a sentence. And one thing to ask yourself when you're answering these questions is this a reasonable answer? And it does seem reasonable. If you would have gotten something like 75,982, please make sure to go back and figure out what you did wrong. If you get 0.08, again, same thing, figure out what you did wrong. Or maybe it's just a bad problem, and maybe you didn't do anything wrong. maybe this person really did kick it 79,000 feet high. Who knows? Um, anyway, moving to B, how far must the nearest defensive player who is 6 feet from the kicker's point of impact reach to block the punt? Okay, so we could see on this diagram that at 6 feet, we're just trying to figure out what is the height. So to do this, all we have to do is, hopefully you're thinking it when I'm thinking, plug in a 6. F of 6 equals negative 0.01, blah, blah, blah. And the answer I got is 8.72. Does that seem reasonable? Yeah, it actually even looks like that considering the graph that they've given us, even though we can't judge exactly by that. Um, but yeah, 8.72 feet. So he would have to reach 8.72 feet high. Now, is that reasonable for him to block it? Sure, it's not saying he has to jump almost 9 feet. He just has to reach that high. So if he's 6 feet tall, is just without jumping, he's already got 8 feet or so. So he could do it. He just has to do it in time. I see if the ball is not blocked by the defensive player, how far down the field will it go before hitting the ground? Okay, so what we're saying is, okay, he misses it. Uh-huh. It's the ground. So we're looking for this point right there. Specifically, it's asking how far down the field will it go? That means we're looking for the X value. Um, when the Y value, think about when it hits the ground, what is the Y value? If Y value is height, we are looking for a place where f of X, and we don't know what X is. We're looking for a place where that's equal to 0. So we have this equation now. So it's a quadratic equation. The first thing you should always do is think, did I factor this? And hopefully that idea is rejected immediately from your brain. Don't try to fix this up to make it nice and pretty. You don't have to get rid of the decimals. It's a terrible way to do it. So should we complete the square? Again, another really bad way. Let's just go right to quadratic formula. Um, X equals negative b plus or minus the square root of b squared. You better know this. I'm going to take that negative and put it right here with that. But minus is going to change to plus. For AC all over 2A. Okay. And your calculator can't do both of these calculations at once. So let's just think about it a little bit. Now the bottom is negative. We definitely want an X value that is positive, don't we? Think about it. The bottom of this fraction is negative. We want an X value that's positive. So the only way for X value to be positive if the bottom is negative is to make sure that the top is also negative. So I'm not going to do, I'm not even going to try to do plus. I'm just going to go right to minus. We're going to have a negative number minus a number that's definitely going to give me a negative number. Now for this in your calculator, I do recommend there's a shortcut. Go ahead and hit alpha and then the button just to the right of that. In between alpha and stat, there's an XT theta N button. And you'll notice that when you hit that, it allows you, if you have the right operating software, most of you do, to enter a fraction. If you don't do it, just make sure the top is in parentheses. Okay, so what I'm getting is, did you get the same thing I did? About 119.7 feet. In my class, I do want 3 degrees of accuracy for the decimal places, so I'm going to put the 671. ask your teacher how much accuracy they want if it's not specified. It does seem pretty extreme when talking about feet, but that's okay. Just to be standardized. 119 feet. Okay, that's pretty far down the field. Cool. And it doesn't look like here because I'm not a computer and I just estimating. It's just a sketch. Graph the function that models the football's parabolic path. The first thing that we need to notice is that this grid is completely unhelpful. Now, why is it unhelpful? Because think about it. How high does this ball get? 36 feet. This grid only goes up to 8. How far does it go? 120. This only goes up to 8. It's super unhelpful. Okay, so I'm going to make my own grid. And also I know that everything's in the first quadrant, so I'm not going to do something like this. That's a waste of space. I have limited space here. I can do this. Okay. The easiest thing to find when you have a function, do you know, well, we already know that's a problem sloping downwards. Easiest thing to find is the y-intercept. You just make x equal to 0 at y-intercept. Y-intercept. F of 0 gives us, see how you could just do that in your head? 2. Okay. That means on my graph, and this supposedly vertical line is bugging me. Let me see if I can do a little bit better job. Okay, that seems vertical. I'm going to start there at 2. The next point I care about happens at the maximum. So after 59 feet, it's 36.81. So I'm just going to put that 59 up here. And up here, I'm going to put 36.81 feet. So I have this point and I have this point. I hope that makes sense. Remember, every parabola also is symmetric about the line of symmetry. So I'm going to imagine this line right here. And with this, I'm going to plot one more point without doing any more real math. Since this length here is 59, I'm just going to go another 59 over here to 118. And at 118 horizontal feet from the kicker, how high is the ball? I'm going to move this so it actually looks a little bit more even. It's 2 feet, right? There's symmetry, that left side and right side. So what I have is that and that. And you can see the last bit of information makes perfect sense considering our answer for C, doesn't it? It's kind of beautiful. Bam. And I'm going to mark that right there. It's always important to mark the important information, and the intercepts are always important. The intercepts, the vertex, those are the important parts of any parabola. So make sure to always mark them. And there we go. And again, you can see that. And if I want to do that here, it would look something like this. No, I'm sorry, it would look something like it goes higher. That's just not helpful. Moving on. Okay, some of these you're going to be able to do just because you're smart and you can figure stuff out. And I don't want you to lose that. Never lose your natural intuition for kind of putting quantities together and just coming up with an answer without using math. But the point of this class is to use algebra, and often just to verify that our intuition is correct. So like this one, you have 100 yards of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? Okay, so we're looking for dimensions and we're looking for the maximum area. I imagine you already know the dimensions. But let's verify. You may want to jot it down on the side and see if it's right. To do this problem, I'm going to start with a diagram. And the diagram is a rectangle, even though I suspect it's going to be a square, which I think you might have done too. I just make a rectangle because it says a rectangular region. So it's an algebra class, so I'm going to label this X. I need a variable. That's called defining your variable. If you just label it on a diagram, that is fine. I'm going to temporarily call this Y. And this other side right here is X because it's a rectangle. This is Y. Now I could do a little work here and say that since I know we have 100 yards of fencing, 2x plus, you know what I'm writing, right? 2y equals 100. And what I want to do is I want to replace that with some expression for x, excuse me. I don't want two different variables in my problem. We'll do that in another unit. In this case, we just want one variable. So I know that 2y equals 100 minus 2x, or y equals 50 minus x. And I'm going to replace those y's with, well, I'm just going to replace one of them. It's too much to have them everywhere. And if you think about it, maybe you could have just gone directly to 50 minus x, right? If it's 100 yards all the way around, that means that just here, that part that I just marked in red, isn't that just 50? And if x yards of that is used for the height, that means the other part has to be to 50 minus x. And if you want to go directly to that, that is fine as well. I'm maximizing the area, which means I need a function that represents the area of the situation. How do I get the area of this rectangular region? The same way you did in third grade. Area equals length times, well, you probably did length times width, right? I do more geometry, base times height. And I'll say x times 50 minus x. And instead of just saying a, I'm gonna write that as a of x, because our x is our input, and then a of x, the area, is going to be the output. Okay, so recognize what kind of function this is. You should be thinking, what kind of function is this? If you multiply this out, you see it's quadratic. Is the leading coefficient positive or negative? It's negative. Yeah, I'll do what you're doing in your head. Writing this in standard form. It's negative, which means this is a parabola that opens downwards, which means it's going to have a maximum value, which is very good for us. We're just looking for that maximum area. How do you find the maximum of anything? By finding the vertex. Okay, so I'll say that x is equal to negative b over 2a, which gives us 25. Okay, so I think I know the dimensions now. If x is 25, then my other dimension is 50 minus 25. So the dimensions, actually it's S. Dimensions are 25 yards by 25 yards. Just as you may have suspected, it's going to be a square. The maximum area, like I could do it just by multiplying 25 by 25, or I could plug the 25 in here, in which case you get 25 times 25, or you could plug it in here, in which case maybe that's the hardest. Maybe that's not a good way to do it. I think the intuitive way, once you have that 25 and then you get 25 here, just 25 times 25, perhaps you know it is 625 square yards. And we're done with that problem. I do want to show you one other way. From here, let's make a quick graph of the parabola. In this form, this is called factored form. This is a really nice way to do this, is to find the x-intercepts of the parabola. Now, how do you find the x-intercepts of anything? By making the y equal to 0. In other words, I'm going to set that equal to 0. To solve this, do you know what to do? Definitely don't distribute. You just use the zero product property, or ZPP. Just x equals 0 and x equals 50. And from that, make a quick sketch of my parabola. 0 is here, 50 is over here. Do you see where the vertex is now? Is it closer to 0 or the 50? Yeah, it's your question, neither one, because we have symmetry. We know that the vertex is going to be right in the middle. But it's not if I found my x value, I could get my y value, and I could draw this. And this is kind of what's going on in my head. And now I know that 25 times 25 gets us at 625. And that is the maximum area. If we would have had just 1 foot being x, right? And like if x is 1, that means the y would be 49. You can see that's not a lot of area. That would be like a 49 down here. And if x is 2, then y would be 48. For the other dimension would be 48, which would 2 times 48, that's obviously more than 49. You can see what's going on here is that it's representing all the different kinds of areas. And when x equals 25, that is the highest area. Moving on. Example, among all pairs of numbers whose difference is 10, find a pair whose product is as small as possible. And what is the minimum product? In this case, you can't draw a picture. Like, I don't even know what you try to do. So you have to define your variable with a let statement. Let x equal the first number. Now, maybe you already know what the second number is, but I'm going to just call it y temporarily for now. Remember, we don't want two variables in our equation, so I'm going to try to replace that as quickly as possible. It says that two numbers whose difference is 10. Oh, before we go through this, could you think of what the answer is going to be? Excuse me. Product is as small as possible. Difference is 10. This is not quite as easy. So let's just let algebra do it. If x and y, if the difference is 10, doesn't that mean that x minus y equals 10? By definition, the difference is 10. Now I don't want that y in there, so I'm going to solve for y. Negative y equals 10 minus x, or y equals negative 10 plus x, which is also y equals x minus 10. So that's my second number, x minus 10. And now that we see this, I hope that makes sense. If the first number is x, then x minus 10 is, there's going to be a difference between those two. You could also do x plus 10. That will give you the same thing as long as you're consistent within the problem. Okay, so I have my representations of the two. It's looking for the minimum product, which means I now need a function that represents the product. Well, the product is pretty easy. Product is equal to x times x minus 10. Those are the two numbers. And I'm going to use function notation again, proper function notation, p of x is equal to x times x minus 10. And what kind of function do we have here? What? It's a quadratic again? It's almost like we're studying quadratics or something. And in this case, the leading coefficient is positive, which means the parabola that it graphs is opening up. Hey, x squared minus 10x. Now you could use a negative b over 2a to continue, but I'm going to use the method I talked about earlier. I'm just going to find the x-intercepts. And you see that quite easily if you use ZPP. 0 and 10 are the x-intercepts. And remember, this is opening upwards, so it looks something like this. And that x value is right in between 0 and 10. Do you know what that value is? Don't use a calculator. It's 5. X is equal to 5. And if x is equal to 5, then that second number, x minus 10, is negative 5. I'm going to say a first number is 5. Second number is negative 5. So there's a pair of numbers. And what's the product? Minimum product is negative 25. Did you consider that? Yeah, that was not quite as intuitive. Someone in class said, well, how about like 90, negative 90 and negative 100? Well, it's true that these two have a difference of 10, but if you multiply them together, you get 9,000. That's a huge product. We're looking for a minimum product. And by the way, negative 90, if you were to look on this graph, negative 90 is like way down on the left. Of course, it's going to be huge. The parabolas go up forever or go down forever, depending on the coefficient. So yeah, intuition, it doesn't always help. And you can see how algebra here took us directly to the answer. Example 9, an accepted relationship between stopping distance d in feet of the speed of a car V in miles per hour is D equals that on dry, level concrete. How many feet will it take a car traveling 45 miles per hour to stop on dry, level concrete? Okay, 45 miles per hour. That is a velocity. So D, I'm gonna use proper function notation here. D of 45 equals 1.1. I just realized I'm talking when you could be thinking and writing. By the way, if you're using your graphing calculator, type all that in at one time. You don't have to do it in pieces. I'm doing it in pieces just because I was being stubborn and I did this in my head. Um, the final answer is 171. So if a car is traveling at 45 miles per hour, it's going to take them 171 feet to stop on dry, level concrete. So if an accident occurs 200 feet ahead of you, what's the maximum speed you could be traveling to avoid being involved? Okay, so we already know that if you're going 45 miles per hour, it'll take you 171 feet to stop. The question is, what's the maximum speed you could be going so that you don't like run into this obstacle? So like 46 miles an hour, 47 miles an hour. Well, in order to do this, we don't know what it is. You don't just guess. We take our function, the 1.1 v plus 0.06 v squared, and we set this equal to 200 because that is the distance that we're trying to figure out, such that we could avoid that, the obstacle. Now let's just use the graphing features on your graphing calculator to help you answer this question. Round your answer to the nearest hundredth. We're not actually going to use the graphing features until we get to part C, but we are going to use the graphing calculator. First step is put this in standard form. Should we factor it? Should we complete the square? Obviously not. Well, if you want a challenge, go for it. I don't think it factors, but you could definitely complete the square. So we use quadratic equation, a quadratic formula, excuse me, negative e plus or minus the square root of, notice instead of plugging in a negative 200, I gotta make this subtraction plus, then just writing a 200 there, all over 2 times 0.06. Oh, I'm gonna just do that part in my head. 0.12. Okay, before we continue, let's think again. Are we going to have to add or subtract here? Which one's going to give us our answer? As a velocity, we're going to want to have a positive velocity. The bottom of this fraction is positive, which means the top should also be positive. If I choose minus, that will not give us what we want. That's why I'm only going to do the plus right here. You remember how to get that fraction in your calculator? Look for it. Did you get what I got? Or 9.29. 153302. Okay, so that means if you're going that speed, it's going to take you 200 feet to stop. So if you want to avoid hitting the obstacle, uh, just go less than that. And it's very difficult to say the maximum speed to avoid hitting this. Um, because, is 49 the maximum? Is 49.3 is definitely no good, but 49.2 is at the maximum speed? Is 49.29 the maximum speed? It's unclear. So it seems like just as long as you're going less than that, 40, just a bit less than that, you're good. And I think that this is a very reasonable answer, 49.2 miles per hour. To avoid hitting oh, it says it does say nearest hundredth. Okay, so it didn't give me a chance to even think about it. And that is less than that, the number, excuse me, 29. It is less than that, so that's good. Miles per hour. Okay. So we're going to do the same question, but we're going to use a different method of doing this. We're going to use a graphing calculator. And to do that, we're going to graph two functions and find the points where they intersect. So since we're solving, put your calculator away. Just a minute. We'll get there. Don't you worry. What we do is we're going to make this y1. We're going to make this one equation. And this is the second equation. You see how it says that in C? Except our calculator doesn't have V's for the graphing function. So it's going to be in X's. And that's where these came from right here. Okay, so let's walk through this together because this might be the first time that you're actually using this function. I have this nifty online version of the calculator. It doesn't look exactly like yours, but it's close enough. So to just plug in the equations, we have to go here, y equals, and that gives us, you can see that there could be up to, I think, 9 equations. I do more than that. Oh, I could do 10. We're only doing 2 though. Okay, so 1.1 for the x, it's this button right here. It's the one that we use for the fraction right next to the alpha. That is x plus 0.06 x. Oops, x. Oh no, I erased it. Did I do it? Control Z. 1.1 x plus 0.06 x squared. Okay, there we go. This is my first one. And for the second one, I'll go down. I guess I have to enter. Okay. 200 right there. Okay. So if I try to graph this, and this is about when you use for the graph, it's up upper right. Uh-oh. I have to hit go to. Something happened here. Oh, I guess this online calculator is not quite as good as I hope, but I'm pretty sure I know what happened. Um, oh man. Okay. Everything's terrible right now. I'm gonna have to do this all over. I have to reload this page. I won't mess it up this time. But see what happens on yours when you hit graph. You'll see that it's not gonna work. And you shouldn't get that same error code that I got. 1.1 x. Thank you for your patience here. Plus 0.06 x squared. Enter in 200. Yeah, so I believe that the problem was that my window was not good. Let me get rid of all this stuff here. We don't need all these ads. Oh, almost missed that one too. Okay. So I'm going to uh, make my window such that it fits everything. Right now, I'm going to -10 and +10 in the X direction, -10 and +10 in the Y direction. But because we're graphing the line Y equals 200, that's a horizontal line that's up at 200. So I'm going to change my window such that do you see how I'm going to go up as high as I need to? A Y max. No, I'm not going to make that Y max 200. I want to go above it. So maybe 225. Okay. I'm hoping and praying now that this will graph. Let's see. Oh, there we go. There's a parabola and there's a line. Okay, it's graphing. I don't know what happened before. Maybe I just mistyped something. Okay, but we're looking for where these intersect, and you can see that we haven't quite got. We see that the parabola is going towards it. We haven't gotten there yet, though. So my window, I need to open up this way. I need to see more to the right. So what do I have to change for that to see more to the right? I have to make sure that what my Y max, excuse me, is big enough. I'm not going to go to 225 because that would mean I'm thinking about going 225 miles per hour. But maybe let's say 70 there, just for fun. Even though it's not really fun. I know I'm just saying that. So graph it now, and oh, look at that. We have the line, we have the parabola, we have a point of intersection. So we are going to use the calculator to calculate that point of intersection. You might be tempted to hit this trace button to kind of trace along one of these. Please almost never use trace, but we are going to use calc. And anytime you want to get this blue function going, you hit second and then whatever button is that has that blue. You see which one we're going to do? Five. Intersect. You can either arrow down or you can just hit a five. Okay. Don't do anything. Just look at the screen, please. I want you to notice what's on here. Up at the top, it says Y1, and that corresponds to the parabola. That is blue and blue. Calculator's a little bit dumb. You saw that we could input 10 different equations. And if we're looking for the intersection of two of them, it's going to ask, which equations do you want? Now, I only inserted two, but it's still going to ask, you see right here, it asks for the first curve. So first curve is on Y1. I'm just going to hit enter. And now it's asking for the second curve. Notice that the cursor has switched to the red one, and up here is Y2. So I'm going to hit enter just to select Y2. And now it's being really dumb because there's just one point of intersection, but it always wants us to guess. In order to guess it, we're going to take that cursor and move it to the right until we're near it. And then it doesn't even have to be that near if it's the only one. I can hit enter now, and the intersection is here. The Y value is 200. X value is 49.291533. Does that number seem familiar? It should. That's what we got just a minute ago. Yeah, so that's how we do this. If you didn't get it, um, go back, go back and listen again. It's important for you to be able to figure out points of intersection on a calculator. Okay, let us continue back with the notes. Okay, yeah, there's one more. Okay. A food truck gyro vendor has weekly fixed costs of $525 and variable costs of $575 for each gyro combo prepared. Let X represent the number of gyro combos prepared and sold each week. Write the weekly cost function C for the food truck vendor. Hint, the cost function is the sum of the fixed and variable cost. Okay. Well, here's a fixed cost. There's a variable cost. So it's just going to function form C of X. So it's 525. That is a flat rate. And if they sell one or they prepare 1 euro combo, it's going to be 525 plus $5.75. If they do two, it's variable. That's why we need a variable in here, where X is the number of euro combos. Okay, so that is C. The function R of X is equal to all that describes the money in dollars that the food truck vendor takes in each week from the sale of X euro combos. Excuse me. Use this revenue function and the cost function from part A to write the vendor's weekly profit function. Hint, the profit is the difference between the revenue and the cost function. Let me read this again. Okay. Profit is equal to difference between the revenue, and we're hoping that the revenue is greater, R of X minus cost X. And we have R of X is negative 0.001 X squared plus 8.95X. That's I just copied that over. Minus C of X. Now you know what I'm going to write next, don't you? Either write it or think it, but I'm going to write it here. Parentheses. Cost function is 525 plus 5.75x. Excuse the background noise if you can hear it. I'm putting this together, negative 1 point at 0.001 x squared. Uh, what is this? 8.95 minus 7.5.75 is 3.2, 3.2x minus 525. Okay, that's our profit. Notice that it's a quadratic function. Leading coefficient is negative, which means it opens downwards. We're going to have a maximum. Right, use the vendor's profit function to determine the number of euro combos that should be prepared and sold each week to maximize profit. Okay. Well, we need to find the vertex. So x is equal to negative 3.2 all over 2 times negative 0.001. The negatives cancel. I know that 2 goes into 32 16 times, so it's the 1.6 divided by 0.001. You better not need a calculator for this. Just multiply top and bottom by 1,000 or move 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah, that's why the answer is 1,600. X equals 1,600, which means, remember, X is the number of euro combos that need to be prepared. To get the profit, we have to plug that into our profit function. So P of 1,600 is equal to negative 0.001, 1,600 squared plus 3.2 times 1,600 minus 525. Get out your calculator and calculate that for me. It looks like the amount of money that they make. The profit, the pure profit, is $2,035. And again, these are word problems. So if this were a test or quiz, you'd be expected to say they have to prepare 1,600 euro combos, excuse me, 1,600 euro combos to get a maximum profit of $2,035 or something like that. Okay, I hope that all makes sense. Yeah, that's all I got for you. And look forward to doing some polynomials next time. Thank you.